Okay, we're going to give it a few seconds for everybody to get connected. I want to welcome everybody on this beautiful Saturday in March in the Lehigh Valley. Welcome to all of you who are joining us from your homes, I assume, at this point in time. I wish that we were able to join you from the heart of our College of Engineering in Rossin, in Packard Lab on Lehigh's campus, but we're more than thrilled to have you join us today in this virtual endeavor for our first open house of the year. I'm Susan Perry. I am the Assistant Dean of the College of Engineering and Assistant Dean of Academic Affairs in the College of Engineering. I'm also a professor in bioengineering, professor of practice, and I'm going to spend just a few minutes with you today, giving you a kind of 50,000 foot view of the College of Engineering, and then I'm going to open it up to have you listen to the thoughts and views of our faculty members and a few of our students here today, because they can do it much more justice than I can. I'm going to start with asking you to think about a year from now, when you are moving into your college experience and thinking about opening this door, being on campus and opening the doors to your future, and what that means to you in terms of being a Lehigh engineer. And that's what we really want to talk to you about today, really. What does it mean to be a Lehigh engineer? When we think about, when I think about Lehigh engineering, I want to say that, first and foremost, I think about our students. I think about the incredible students they are in terms of their ability to come to understand that engineering is about humanity. It's about being eager and engaged and wanting to address the big challenges of society through their academic training, through the use of the resources on campus, through the incredible assistance of our state-of-the-art facilities and our faculty who are engaged at the forefront of their disciplines to make things happen. And that's really, I think, the hallmark of Lehigh engineering, bringing together the students and an engaged faculty and a rigorous academic curriculum. And what comes out of that is innovation and problem solving and solutions to some of the world's most critical problems. So how do we do that? We do that by giving students an opportunity to engage in curriculum in 8 academic departments with faculty that is about 150 strong. We offer 19 Bachelor of Science programs, 11 of which are ABET accredited, and I'll bring those up on the next slide. We offer degrees in engineering across traditional engineering disciplines, from bioengineering to civil engineering, electrical engineering, as well as some engineering disciplines that you may not find in all universities, such as industrial systems engineering. There's also a rich array of interdisciplinary programs at Lehigh, from 2 programs which are honors programs to which students apply when they apply to Lehigh, and they have to be admitted to these, in integrated business and engineering, blending obviously a degree in business and a degree in engineering. This can be done as a 4-year program or a 5-year program. There are integrated programs which allow you to blend engineering with training in College of Arts and Sciences through both the integrated degree in engineering, arts and sciences, as well as a 5-year program in arts and engineering, where you get accredited degree in engineering, as well as a second dual degree in the College of Arts and Sciences. There's also a host of opportunities to bring in any kind of training in areas of passion to students. Students blend all kinds of minors. They blend degrees in multiple departments. So there's a wealth of opportunity in terms of creating and crafting curriculum that really meets the needs of each individual student. And in a way that speaks to their passions, that captures their interests, and allows them to do great things after Lehigh. Now, when you think about engineering and you think about the different engineering disciplines, each discipline is really a unique blend of courses. It's a unique blend of math classes, science classes, engineering design classes. And if you're looking at bioengineering, you may have a greater concentration in biology and chemistry and related sciences, whereas in mechanical engineering, you may have a greater concentration in physics and mechanics. Regardless of the unique blend of courses within each discipline, what's really central to all of our academic curricula is this idea that project-based learning is really core and critical to our students' learning. Being able to take the concepts learned in the classroom and apply them through hands-on experiential learning opportunities is what's really key to an engineering degree at Lehigh. Students do this in conjunction with the resources that are available to support their learning. There are 12 research centers, interdisciplinary research institutes. Every single discipline, every single major has dedicated teaching labs that are specifically geared towards giving students those hands-on opportunities, whether it be directly in the lab, pouring metal or building prosthetics, or virtual labs where their hands-on technology experiences are really going to be key and critical to giving them the professional development skills that they need to go out and make an impact at beyond Lehigh. Our students are engaged in an incredible amount of opportunities that support their curriculum. They are engaged in research with faculty at the forefront of fields. They engage with graduate students and faculty alike to create new knowledge, to engage in solving problems in a variety of fields, whether that be working in bioengineering applications for point-of-care diagnostics, to creating new materials for application in technology spanning across different fields, to working in optimization within the industrial systems engineering department. They are engaged in internships and co-ops that are giving them those hands-on opportunities both at Lehigh, in the local Lehigh Valley community, across the country and across the globe. These opportunities are almost always to create impact again on the national or global stage, to positively impact the world around them. Students are engaged with resources on campus that help them expand their entrepreneurial footprint. It helps them expand their networks with alumni. They engage with faculty, students, and colleagues across disciplines within the campus. They are certainly engaged in student clubs on the personal level, whether that be for feeding passions outside of engineering, such as music or ultimate frisbee. But those clubs also are a mechanism by which students can gain technical training that can augment their coursework and curriculum as they look to gain skills, again, to be able to position them for the careers that they want outside of Lehigh. And we do this, again, we offer those opportunities to our students through our curriculum beginning during the first year. We offer all of our students a common first year experience, which is centered in math and science, engineering, design, and computations. And we also include writing and electives, which are going to assist students in their communication skills, in allowing them to look at the world holistically. Because it's really important as engineers that our students are able to view the world through the lens of multidisciplines. And the curriculum at Lehigh allows us to do that right from the very first year. Again, I said that our students are engaged in hands-on learning. It's a key point of our engineering curriculum. Those hands-on experiences are done largely through project-based experiences across the curriculum. It also occurs through internships and co-ops, and it occurs through student experiential clubs. It occurs through our usually capstone design courses in all of the engineering disciplines, where students really take the curriculum that they've worked on through 3 years and begin to apply it to real world applications through connections with companies. All of these experiences wouldn't be possible without another really key aspect and hallmark of Lehigh, which is the faculty engagement. I'm amazed every day that I get a chance to interact with my colleagues, to see them on the forefront of their research endeavors, to learn about the incredible discoveries that they're making and the impact that they're having on their fields. And they're doing it in a way that they allow their students to be partners with them. They're not just colleagues to me, but they're partners with their students. And that is absolutely just amazing to me every day. I'm thrilled to be a part of that. It's one of my favorite parts about being at Lehigh, is watching students engage with their faculty to create amazing things. As you can tell, collaboration is key across Lehigh. It is why I am still at Lehigh after 21 years. It helps me learn every day. It helps our students learn every day, and it's one of the most incredible parts about Lehigh. While we have this system set up for our students to gain training, the kind of rigor that they need to be active and productive participants in their fields, we do offer lots of flexibility in the programs, and engaging with faculty is one of the ways that our students can kind of build that flexibility into their curriculum, by having partners in mentoring and partners in advising. And very often students will come into college not knowing exactly where they want to be, having an idea that maybe this path is right for them, and determining not too long after that maybe I need a different path. There's enough flexibility built into the curriculum at Lehigh that it's not a big hurdle to switch a major, to switch a college. We work with you as partners to have you have the absolutely best experience that you possibly can have as a student at Lehigh. And with that kind of 50,000 foot view of Lehigh engineering, I'd like to open it up to introduce my panel here and move into what I consider to be the best part of this presentation today, in that you get to hear a little bit more about their thoughts about and experiences of Lehigh, and what makes Lehigh engineering so special. And so I'd like to introduce our panel today. We have Professor Mizu Purvispour from Civil and Environmental Engineering, Professor Terry Hart from Mechanical Engineering, Professor Mark Snyder from Chemical Engineering, Professor Leslie Chow from Material Science and Bioengineering, Professor Larry Hertz from Bioengineering, and our newest major, Biocomputational Engineering, And we have two students with us today who have a wealth of experiences that I am excited to have them share with you. We have Allison Cody and Amanda Morrison with us today. And as I move into the next segment, I'm going to leave the slide up just for a moment for you guys to capture their emails should you want to connect with them again. But then I'm going to turn off the screen share, and I'm going to ask each of our panelists to tell us who they are. I've already told you where they're from in terms of their disciplines, but if you can tell us a little bit about what you do here at Lehigh, and then maybe one fun fact that is not on your resume that you'd like to share with us. Okay, I'm going to start with the students. I'm going to start with Allison.
Thanks, Professor Perry. Hi, everyone. I'm Allison. I'm a junior in the engineering college, and I study computer science and health medicine and society through Lehigh's IDEAS program. So I came into Lehigh not really knowing what I wanted to major in. As Professor Perry said, there's a lot of opportunities to kind of explore. So Lehigh's great for that. And I kind of came onto computer science through one of our core first year courses, Engineering 10. I really loved that experience and continued down that path. So if you have any computer science related questions, I'd be happy to share my experiences there. You definitely have lots of opportunities to explore at Lehigh. In my free time, I'm involved in the Society of Women Engineers. I help plan an event called Choices, which is an outreach event for middle school girls that we have every March. It's coming up next week, super excited for that. I'm also involved in the Rossin Junior Fellows, which help with outreach events like this for the College of Engineering. And more of social fun side of things, I've been in our jazz band here at Lehigh, and I play on the Ultimate Frisbee team. I guess one thing that's not on my resume for a fun fact, I might be stealing Amanda's because we did this together, but when we got that massive snowstorm in Pennsylvania this year, we hiked to the top of the mountain at Lehigh and skied down. It's a lot of fun.
I also slid down my hill multiple times in the snowstorm, not from Lehigh, top of Lehigh, but I have a big hill in my yard as well. Always fun. Amanda, how about you?
Well, Allie did steal my fun fact there. We're both on the club ski team here as well. But so I'm Amanda. I'm a junior in the IBE program, majoring in industrial systems engineering and a dual degree in finance and a minor in computer science. And then outside of the classroom, I'm the vice president of the Society of Women Engineers. I'm an orientation leader. I'm in Rossin Junior Fellows, which is how I'm speaking to you all today. I'm a TA for an Introduction to Java class. I think that's everything for me.
No fun fact? You're not gonna share another fun fact?
No, they always tell me to have these prepared for orientation, but she really did take mine. I was planning it too. Fun fact, come back to me. I'll think of something.
Okay. All right. Terry, how about you?
I'm sorry. Yeah, I didn't hear you, Susan.
Yeah, you were on mute.
I probably hit my mute beforehand. Yeah.
Good. Yeah. Hi, I'm Terry Hart, and like Susan, I graduated from Lehigh just a few years before she did, many years before she did, and in mechanical engineering, the same department I teach in now. And, I went off for graduate school for graduate degrees in both mechanical and electrical engineering. Went to work for Bell Laboratories. I went in the Air Force, flew fighters mostly on the weekends for about 20 years. Ended up being picked up by NASA. I had the honor to be one of the first space shuttle astronauts, and flew in the space shuttle years ago. Kind of came back to AT&T and ran their satellite business as the head of engineering, and then the president eventually for a few years. Then I had the good fortune to retire about 15 years ago and come to Lehigh. So I've been teaching for about 15 years now, and I love it. Mechanical engineering, let me say, is a very broad discipline. We train our engineers to do everything from make machines to manufacture a pen like that. to designing spacecraft and trajectories to the moons of Jupiter and everything in between. So it's a very broad area. And if you're not particularly focused on one particular area, don't know what kind of engineering you want to do, mechanical engineering is a good choice. We're a very large department for that reason as well. I focus mostly on the aerospace courses, given my background. So these are courses that didn't exist, when I was a student, but now we have propulsion and astrodynamics and all kinds of fun courses that I enjoy teaching for the students that, as Susan said earlier, take a minor. We have a minor in aerospace, minor in energy, or you can minor in computer science and so forth. All those things are possible here at Lehigh. So yeah, so fun facts. I'm not on my resume. I love to do woodworking. I have an old barn here on my property, and I spend many hours out there building furniture and making gifts for people. So that's my fun fact. Back to you, Susan.
I'm thinking I could use some gifts.
I'll keep you in mind.
How about you, Mark?
Sure, I'm always happy to follow Terry, but then also sad because he has a great story about being an astronaut and I'm not, right? But I do share the something in common. I also graduated from Lehigh with my BS in chemical engineering back in 2000, and then after pursuing graduate school, came back on the faculty and have been enjoying it ever since. So I am on the faculty in chemical and biomolecular engineering here at Lehigh. I teach a range of courses. A course that I've taught for many years now is actually a junior level course in the major. That's essentially an applied math course for chemical engineers. So essentially taking, all of the sort of chemical systems that we work with and thinking about how we represent that in a mathematical model, and then also understanding how do we actually solve that mathematical model and make some predictions and some analyses. I also teach an elective course that's closely related to my research. So this is an elective course that's actually both at the undergrad and graduate level, and it's focused on porous materials. So my research in my lab with graduate students and undergraduates is really focused on porous and functional nanomaterials, with applications ranging all the way from sort of the energy sector to some environmental applications as well. I guess a fun fact. Outside of actually graduating from Lehigh, I have 2 young daughters. I hope that they'll be sitting on one of these calls in quite a few years, right? Thinking about pursuing maybe a degree in engineering. I won't push them that direction, but only encourage them. I've had the pleasure, I'll call it sort of pleasure, for the past however many months doing a lot of homeschooling during the pandemic. And so I not only am a professor, but also, a homeschooler of a 6th grader and a 3rd grader, which I'm not sure which is more challenging. So.
Thanks, Mark. I am the parent of a Lehigh student currently, so I too sat in your seats wondering whether my son would come to Lehigh as an engineer. He did not, but he's at Lehigh, so I got half of it. Dr. Chow, how about you?
Sure. So I'm just glad I didn't have to go after Terry Hart. But Mark, I didn't actually know that you went to Lehigh, so that's really exciting. I learned something new. So everyone before me was listing off all their credentials, and so I was trying to figure out how I could pack my list of things a little bit more. But it turns out I don't really have a ton to say. I didn't go to Lehigh. One of the big reasons why I like Lehigh is because in 2012 they beat Duke University in basketball. And I really dislike Duke University, so that was a big motivator for me to come here. So I am an assistant professor in material science and engineering and bioengineering, which I just realized when we were talking about the different departments, that I'm part of one of the oldest departments as well as one of the newest departments. So I'm jointly appointed. So material science and engineering is celebrating their 130th year or 131st year this year. Whereas bioengineering, I think we're celebrating our 4th year officially as a department, although we've been around for quite a long time. So my research is in biomaterials, which makes sense because of my cross-disciplinary appointments. And I'm interested in musculoskeletal tissue engineering. So I'm really trying to regenerate hard soft tissue interfaces. So bone cartilage, tendon to bone, ligament to bone. From an engineering perspective, nature did a fantastic job making these materials. But I did a really fantastic job personally destroying a few of those, playing soccer growing up. So I'm highly motivated to get some of the technologies into the clinic to heal myself. A fun fact about me, I forgot to think about this. So this is a little weird. I am really good at estimating volumes. So if you ever need me to fit your leftovers into a Tupperware container, I am the person that you want with you at all times. So I'm really good at that. Or like the weight of things that are under a kilogram up to maybe like, yeah, I think I'm pretty good at estimating volumes and weights within like relatively small error. So, yeah.
Are you good at packing a car trunk? Because I could use that.
Yes. If you need like anything that involves spatial volume, something like that, I'm very good at like that sort of thinking, 3D thinking.
Excellent. Excellent. Professor Purvispour, how about you?
Hi, thanks, Susan. Hi, my name is Mesut Purvispour. I'm from Civil Engineering Department. I am a professor of practice. As I listen to everybody, I hear how much common things we have in here. I didn't do my undergrad at Lehigh, but I did my second master's and PhD at Lehigh. I was happy to come back here. My main responsibility is teaching. I've done research on many things from flow in porous media, coupled flow, to health monitoring, real-time monitoring of our bridges, to developing fiber optic sensors, or bulletproof vests, whatever you think. But now at Lehigh, I enjoy doing projects with students. I mostly teach classes in project management, several sequences in that, some courses in structural analysis and geotechnical engineering. Something that's not on my resume, I have a school and teach in Aikido. I'm a 5th degree black belt in that. And a fun fact, a couple of my students are working as a part of their independent study, trying to analyze sustainable transportation alternatives on campus at Lehigh. And one of the things that they're looking at is whether they can come up with a gondola design for our campus to transport students. So and I'll be very happy to answer any questions that you have about civil engineering.
If that gondola can go from the Asa Packer campus to the Mountaintop campus, I'd be even more happy as somebody who's
Let's keep our fingers
spends a lot of
crossed.
time up on the mountaintop. For those of you who might not realize, Lehigh has 3 campuses located pretty close to one another, but one of them is quite uphill from the others. So, Professor Hertz.
Good afternoon, everyone. Thank you for coming today. My name is Lori Hertz, and I'm the Associate Chair of the Bioengineering Department. I'm also a professor of practice, and I teach a number of bioengineering courses. As Associate Chair, I'm responsible for 2 undergraduate majors in our department. The first is bioengineering, and the second is biocomputational engineering, which is a brand new major at Lehigh. That's really at the interface of bioengineering and also computer science. So I can tell you a little bit about that a bit later. The classes I teach 2 upper level electives. One is metabolic engineering, the other is quantitative biology. So both of those involve a lot of cell biology and biochemistry, but with mathematical methods applied to describe biological phenomena. I also teach courses in FDA regulations. One is a course that's required of all of our bioengineering students, and then the other is an elective on more advanced topics. In addition to teaching, I advise some capstone design projects. I also do a lot of undergraduate advising, and also I lead a Creative Inquiry Project. Creative Inquiry is a program at Lehigh that is similar to research, but the projects tend to be a bit more student-driven than faculty-driven. And many of the Creative Inquiry projects relate to global health. And the project I lead, I have a group of students who are developing products to alleviate micronutrient deficiencies in children in Sierra Leone. So I've been working on that for almost 3 years now. Additionally, when it's not a pandemic year, I'm the faculty leader for one of the Iacocca International Internships. These are summer programs where students can go really anywhere in the world. And several times I've led an Iacocca internship at Technion Institute in Haifa, Israel. So I've had a group of small students traveling and working for the summer for that. Fun fact about myself. So when there's a snowstorm, I tend to not go skiing or sledding. But over the last couple of years, I've been doing a lot of cooking, but I don't like to follow recipes. I like to do my own thing. And maybe a more pandemic focused activity is doing outdoor Zumba classes and Zumba videos, but I have to say I am a better cook than I am a Zumba dancer.
Are those Zumba videos published anywhere? Or
Right, so actually the Lehigh Fitness Center has Zumba classes, which you can attend online live, but they also record them. So there's a library of a lot of fitness center classes. So I usually do that.
Okay, that I feel better about rather than there being videos out there of you doing Zumba.
Oh, no. That's not happening.
Oh, funny. Well, I think in the next segment, now that we have a kind of an understanding of what each of our panelists do, I'm going to ask the faculty panelists to tell us a little bit more about the question I want to ask is, how do you define your discipline, and what makes your program unique at Lehigh? I'm going to start with Professor Chow.
Sure. So I'll speak, since we have a bioengineering representative here, I'll speak only for material science and engineering. So one of the things that I think is really cool about the material science and engineering discipline is that we have a lot of hands-on labs. And by that, I mean, we also have a world-class microscopy suite, meaning we have these really extremely powerful microscopes that can look at the atomic scale. And when I mean atomic scale, I mean we can see atoms with these microscopes. And students get to use these instruments. So part of your undergraduate training, you're in the labs, you're using the microscopes. It's not you watching somebody use a microscope or you watching a video about that. You're actually in there. And all of our labs, it's, I can say from my own experience, it's a lot more hands-on than what my own undergraduate experience was like. I went to the University of Florida. So we have these labs that you go in and you're actually running your own samples, you're characterizing your own samples, you're analyzing them, you're understanding, you're trying to figure out what things are. And what I like about it is you figure out what something is, how it's made, and how that contributes to its performance as a material, but also cool things like how did it break, right? So we have a failure analysis class where you look at why something failed and try to understand how could we prevent that. So from an engineering perspective, I really like that the hands-on activities and all the way, across, these different types of materials, you really get to think about what's contributing to their properties. So, I encourage everyone on the call to look around your house and think about, why is that made of this? Why is this made of wood? Why is this made of metal? What would happen if it were made of something else? And just know that materials are all around us. I also would like to comment on the cattail that I'm really enjoying.
Thanks, Leslie. Mark, how about you? Tell us a little bit about what is unique about chemical and biomolecular engineering at Lehigh.
Sure. So generally, chemical and biomolecular engineering, right? We the coursework is fundamental sciences, chemistry and biology combined with math and physics, sort of a pretty nice balance. Susan had talked about, sort of the breadth of coursework. And then ultimately coming together, trying to think about giving our students the skills to be able to essentially design large scale chemical plants with sort of the main goal in the end, being able to go from what you get from sort of small scales, maybe on the lab bench in a chemistry lab and biology lab, and how do you scale this up into producing very large quantities of some chemicals, commodity sort of products, so on and so forth. And so at Lehigh, certainly we're looking to give our students as rigorous a training as possible. I think unique to our program are a couple things. Certainly along the way, giving students a chance to do some hands-on sort of things in the lab. But ultimately in the senior year, our students spend both semesters the senior year in what we call our unit ops lab. It's a state-of-the-art lab that actually has individual sort of pieces of equipment that are representative of essentially units that you would find in a chemical plant. And it gives our students a chance to come with all the tools they've gained during that the coursework and really apply it in the lab. Even though there's standard sort of equipment and experiments to be done in the lab, there's flexibility given to our students to essentially design their own experiments, think about what they're interested in trying to explore with the equipment. In addition, our capstone design course in chemical engineering pairs students with industrial representatives who bring real world chemical and biomolecular engineering problems to the groups and challenge the groups to essentially go start to finish with a full-blown design of a chemical plant, the economics, the safety components, so on and so forth. And so I think that those opportunities, along with all of the opportunities, and maybe we'll get a chance to talk about this later, that engage in undergrad research in a whole range of faculty labs doing a lot of quite different sort of research, really distinguish our program and give students some pretty exciting opportunities to build on.
Thanks, Mark. Terry, could you tell us I know you talked about mechanical engineering being very broad. How would you define the discipline of mechanical engineering to students wondering about it?
We take away all the special things like biochemical, et cetera, electrical, and what's left is mechanical engineering. Basically, it's all every industry essentially hires mechanical engineers. And you're right, Susan, it's the thing that distinguishes our department in that sense is the broadness of it. Yet, like Lehigh itself, we make it easy for students to bring in courses from outside of our department, outside of the College of Engineering, from other colleges at Lehigh, and combine them in a way that meets their needs, perhaps even with a minor. So we do that by having 5 technical electives, which are in the junior, mostly in the senior year. And then there are 2 free electives as well. So there's 7 courses, 21 credit hours there, where if you want to stay within our department, you can get a minor in aerospace engineering or in energy, for example. But if you want to go outside the department, you can actually bring in any technical courses. If you want to get a minor in astronomy, for example, you could bring in some courses from the physics department in astronomy. Computer science is very popular to bring that into our curriculum. So broad yet flexible, I think, is a distinguishing factor that we try to support our students' interests beyond just the basic bachelor degree in mechanical engineering.
Great. Professor Poor, tell us a little bit about civil environmental engineering from your standpoint. What's a good description of that? How do you capture that description and the components of it? And what's unique about Lehigh's program?
Well, what's unique about Lehigh's program, for almost as long as it's being very nationally recognized and globally sought out program. So civil engineering department is highly ranked within the global civil engineering departments. The discipline itself basically I can break it into 5 pieces that makes more sense. One component is structural, that you deal with the components that you see, buildings, bridges, and things like that. The other one is geotechnical. These things have to sit and housed and be supported by the ground or within the ground. The other one is water resources, which means we deliver, we bring, we process all these things. And other one is transportation, physical components or planning of those, and designing and laying out and operating those. And last is the environmental, which actually our civil and environmental engineering discipline here at Lehigh has 2 degrees. One of them in civil engineering, the other one is in environmental engineering. Environmental engineering focus will have a little bit more focus on topics like bio and chemistry in it, whereas civil engineering one will have more physics and mechanical components in it. As civil engineers, we kind of deal with problems that are that basically establish our civilization. All the large scale things that you can think of, infrastructure components, in a relevant way for today's problems, where we're dealing with global challenges, you can say, things like climate change, where we have to deal with water distribution changes, or rising sea levels, or resiliency of our structures to natural disasters and things like that, long-term effects and design. Our undergraduates basically work, like in any department in civil engineering, with state-of-art labs. Some of them our labs are buildings, actually, entire buildings. We test 2-3-story buildings in those buildings. So when we talk about large scale, we're really talking about large scale. So students enjoy being able to have hands-on practice, bring whatever they're learning in the class and see its effects and relate to it and build and test it. Like Dr. Chow mentioned, we break things, we learn from breaking things. That's the fact of things. You basically learn what the laws and how things operate by reestablishing those understandings. So students being part of it helps them a lot to actually take responsibility in their own learning and actually become a partner with us. So that's the strength of civil engineering department as any other department at Lehigh.
Professor Hertz, how about bioengineering? And if you want to do biocomputational engineering, that could be true too. You can do that too.
Sure. I'll start with, I guess, a brief definition of the 2 different fields. When we say bioengineering, we mean the application of engineering principles to medicine and biology. And bioengineering at Lehigh has a definite healthcare emphasis. So our curriculum includes biological sciences, chemistry, and physics courses, as well as a core of engineering courses that really emphasize problem solving and hands-on learning. So one of our strengths of bioengineering is all of the advanced lab courses that our students take. Those sections tend to be small, typically 5 to 10 students. So there's a lot of faculty-student interaction, and the students get to play with some cool equipment. And then in biocomputational engineering, I mentioned before, it's the study at the interface of bioengineering and computational data sciences. And we just launched that program this year, so we're excited to have our first cohort of students. So the computer science courses that the students take include programming, data modeling, and machine learning. And over the years, our students in bioengineering have traditionally gone into the industries related to medical devices, pharmaceuticals, biotechnology, and especially in the last 5 years or so, we've had an increasing number of students going into healthcare analytics. And based on that and the increase in research in this area and the number of graduate programs, we at Lehigh decided that we wanted this to be an undergraduate field of study also, because there are very few countries, or there are very few universities in the United States that offer undergraduate study in this field. So an interesting fact about bioengineering at Lehigh is that the student body is about 60% women, so more than half are women. Oh, and I guess also I'll mention that a lot of our students do research as undergraduates, as the other faculty from their departments have mentioned also. So one nice thing about most majors is that you can do research for academic credit and count it towards your bachelor's degree in that particular field of engineering.
Thanks, Lori. One other thing I'll also mention about both the bioengineering degree and also the chemical engineering degree to some extent. It provides a basis for students who are interested in moving on to professional, pre-health professions as well, such as medical or dental school. The curriculum, the courses built into the curriculum align very nicely with the pre-med, pre-dent PA curriculum as well. So if students are interested in those kind of opportunities, there are ways to manipulate your schedule appropriately to incorporate those. And it can be done for all engineering disciplines. I'm the pre-health advisor for the engineering college, I think, certainly for bioengineers and chemical engineering students, but I have occasionally had mechanical engineering students and I'm thinking material science students who have been interested in, at some point in time decided that that's the path they want to take, and they can still blend the unique problem solving and analytical capabilities that an engineering training and curriculum gives to you, and apply that to a lot of health fields in terms of clinical care. So there's been at least one question in the question and answer about when students choose their majors, and I know, Allison, I think it was you that said you came in not being quite so sure about where you wanted to head in engineering. Did I remember that correctly? Okay. Can you tell us what the benefit of kind of working through the first year curriculum was in terms of allowing you that space to decide?
Yeah, absolutely. And that's one of the reasons I chose Lehigh, was how fluid the curriculum is in terms of not having to come in knowing you want to do one thing and starting off with that and going down that path. I had the opportunity to explore different options. So I'm in the ideas program. So my experience is a little bit different. We have a first year seminar where all of the students in my program come together once a week, and we have discussions on ethics in different engineering disciplines. So through that lens, I was able to kind of explore the different fields and get the opportunity to see what each of them is like. There's also what kind of was the main course that drove me down the computer science path was there's Engineering 10, which is a programming course all first year students take, because with our increasingly tech-driven world, it's important that all engineers have fundamental programming knowledge in languages like MATLAB, which mechanical engineers use a lot, and Arduino, which is a microcontroller that also comes in handy in different disciplines. So that kind of sparked my interest. But if you're not in the ideas or IBE program, you take a first year seminar. I think it's Engineering 96. It was called something different in the past. So correct me if I'm wrong there, but the students are able to go to presentations from all of the different faculty their first semester, and kind of in a classroom setting get an idea of what each is like, and then they pick a few that they're more interested in, and they have hands-on labs that give them more experience there, so they can have the opportunity to explore different options. And I know a lot of people come in, even if you think you know something, through this course, you're able to explore different options. You might find out that you love another program even more. So I think that's one of the best things about Lehigh, is that they have that flexible curriculum in that first year, so you can really be certain that you're in the right major.
It also gives you an opportunity to learn about things that you never even knew existed. I didn't know industrial systems. I didn't know anything about what industrial systems was until I started listening to those Engineering 5, the intro to engineering course overviews that kind of led me to understand things about that, and to understand how impactful materials are on the world, right? So again, material science is another one of those that I just didn't really know what it meant. So Amanda, can you tell us a little bit about some of the experiences that you've had at Lehigh, experiential learning, that have added to your to your body of knowledge and in a hands-on way, or in an application-based way?
Yeah, I'd love to. So, like Allie, I wasn't really sure what I wanted to do at 18. It's very different now at 21. But so I changed my major 3 times, and I think all this experiential learning really helped me find where I'm supposed to be. So I came in as a bioengineer. I talked to like a lot of professors about that, and ultimately decided I didn't want to go into healthcare. So I switched to mechanical engineer. I got an internship at a mechanical engineer design firm, which was a super great experience, but ultimately I decided it wasn't for me either. And then I got to switch again into ISE, and I was supposed to go abroad last summer to take Germany to take industrial engineering credits there. I was going to go to like learn about manufacturing. We were going to go to like car plants. It was going to be a lot of fun, but coronavirus. So I did that online, but through those things and like through being a TA and mentoring other like underclassmen now, it's really helped me shape my path. And I think if I hadn't come to Lehigh, I probably still would have been a bioengineer. I probably would have been happy doing it, but I love my major now. Like I'm in the hardest class for industrial right now, and everybody is like, this is so hard, this is so hard, but I love it. Like I love that class. Like I do that homework and I enjoy it. So I think that's like how you know you're in the right place for you, and like it might not be like kind of direct path, but like you will find like what you love.
Allison, how about you? What kind of experiences have you added into your educational package that have, kind of been defining in terms of experiential learning?
Yeah, so that's another one of my favorite things at Lehigh is all of those opportunities. I've tried to take advantage of as many as possible. So I'm currently on a co-op, I'm doing research, and I've been a part of the Mountaintop program at Lehigh. So for my co-op, I'm working at Merck right now. I'm a scientific programmer intern or co-op. So I'm working with some of their preclinical imaging devices to help data transfer between the like CAT scan, PET scan machines and the system where they keep all of the images for the trials. So that's been a really great experience, and I get to combine my passion for computer science with the other side of my ideas degree in health medicine and society, and do something I'm really enjoying. So that's the opportunities for co-ops at Lehigh is a great experiential learning feature. I also do research in the College of Health. I'm helping its coronavirus research. We combine mathematical models with expert predictions to make what's called a meta forecast and predict how the COVID will be spreading through, make predictions on how it will be like 2 weeks out, 4 weeks out, things like that. And then the Mountaintop program, Professor Hertz mentioned the creative inquiry, where it's student-driven research projects. Mountaintop's an extension of that. So there are summer projects, which you would usually be in Building C, which can't tell if that's Iacocca or Building C behind Professor Hertz, but you're on Mountaintop all summer long for 10 weeks. And you're collaborating with a faculty member and a team of undergrads and sometimes grad students as well to drive this project. And you get to collaborate with multiple disciplines. And ultimately, at the end of the summer, there's a big expo where you get to share your work. So I did that 2 summers, and it was a really good experience.
I have yet to hear from a student who participated in one of the Mountaintop projects over a summer who did not say it was a really cool experience. I think that opportunity to be the driver of a project and see where making connections and delving deeply into the background and the market will lead you is pretty eye-opening for most people. I'm going to switch back to the faculty panelists for a second, and I know we don't have too much time here yet, but just as a kind of a way for you guys to tie up some things, what would you say is a defining experience for students in your department and or programs, one that you perhaps haven't mentioned thus far yet? I'm going to start with Professor Hertz, actually.
So I've talked about research a bit and how beneficial that can be, but I think one of the experiences that I have not mentioned yet is capstone design. All of our students in bioengineering, as well as mechanical and material science and engineering, take a common design course, and all the students in the bioengineering major work on health-related projects. It could be, it's often the design of a medical device. Sometimes it's the design of a healthcare system. Sometimes it's a bioprocess. So the students work for 2 semesters. It's junior spring and senior fall on the same project. It can be defined by an industry sponsor, or sometimes the faculty develop projects also. The students work on a team of, say, 4 or 5 students, and they have a faculty advisor as well as a sponsor of the project. So really, it's a nice way for them to integrate what they've learned in their prior coursework. And it also gives them some hands-on experience where they make prototypes, they test the prototypes, they run simulations and so forth. So in addition to getting that technical expertise and doing something real world, they also learn a lot in terms of professional development, how to communicate your ideas and how to communicate what you've done. So that's usually done through presentations and also through written reports. So I'd say our capstone project is one of the hallmarks of the curricula.
I'm going to switch it over to Professor Snyder, because chemical engineering does a different kind of capstone for their students. You want to talk about that for just a second?
Yeah, sure. I had mentioned it in passing at least before, but ultimately chemical engineering has sort of a unique capstone course in which it's ultimately the 2 semesters of the senior year. It groups students in small groups and pairs them with industrial representatives who essentially bring some real world industrial problem to the students and work with them to design from very start a full-blown chemical plant. This is all done, with computational sort of aids, and look at a whole range of aspects associated with that particular design, ranging anywhere from sort of the technical components to safety to economics. There's opportunities to essentially work in a group, in a team sort of setting, right? Work closely with an industrial collaborator, make presentations, be able to sort of hone your sort of presentation skills. And uniformly students in our program, when they leave, point to that as a real defining sort of component to the program. It gives them a chance to essentially pull all the pieces of the puzzle together. They've seen bits and pieces along the way in terms of coursework, and it's a chance, along with sort of the hands-on unit operations lab, really to put that on the senior year, all the pieces together, hone sort of those sort of skills and decide which are the important things sort of to take forward with them, whether they're looking at an industrial position or even if going into grad school. These sorts of this sort of review, if you will, and connections at the very end, I think is found be quite helpful by our students.
We've got about 1 minute left, so I'm going to give Professor Purvis for just 30 seconds.
All right. Well, I think we forgot to mention about our co-op program, right? That the students from many departments, they can actually use a summer and also a fall semester to work at a company without having to go beyond their 4 years. So that's one attractive thing that the Lehigh students really enjoy doing besides the regular internships, to do their co-ops. So that applies to all our engineering programs. So maybe that would be something worth mentioning.
All right, I'm going to give Professor Hart 30 seconds to tell us a defining feature of mechanical engineering.
Well, I have to agree with my colleagues. I mean, when a student has a chance to take what they learn in the classroom and apply it to a real world problem, that's the nicest experience you can have during your undergraduate years. I have 2 teams right now, 5 students on each team. They're juniors, they're juniors going their senior year next year, and they're both working on NASA projects where we've arranged licensing of some NASA technology for basically a quad rotor that takes off vertically, then transitions to forward flight. So they're designing applications for search and rescue. The other team is looking at delivering small packages like Amazon's talking about doing. So to be able to take everything they learn in class and to build that kind of prototype and do the marketing and all the other aspects behind that is a real opportunity.
Awesome. I know we're just about out of time here, so I just want to say, end by saying that, you may not know what you want to do today or what you want to pursue in college exactly, or what to do with the rest of your lives. Some of us still don't know what we want to do with the rest of our lives, kind of. But what we really want you to understand and walk away from today thinking is that, Lehigh is going to do everything it can to give you the tools and the technology and the resources and the connections to find out what resonates with you, to push your own boundaries, to figure out where you want to make a difference. And that difference can be in a large group or small or at global level or for your neighbors. But when those tools and opportunities and resources come together with curiosity and will, amazing things happen. And amazing students like Allison and Cody and Allison and Amanda today have kind of showed you. We'd love you to be part of it. So thank you for your time today. We're really happy to have you join us. And please, I know our